This video will cover difficult questions relating the topic of maximum, minimum, and critical numbers. Question 1. Using the product rule, uv prime equals u prime v plus uv prime. F prime of x equals x prime times square root of 9 minus x squared plus x times square root of 9 minus x squared prime. d dx of square root of x equals d dx of x to the power of 1 over 2. Using the power rule, 1 over 2 times x to the power of 1 over 2 minus 1 is 1 over 2 times x to the power of minus 1 over 2. Then we can rewrite as 1 over 2 square root of x. Then d dx of square root of u equals, using the chain rule, 1 over 2 square root of u times u prime. Then back to the original, x prime is 1, then square root of 9 minus x squared plus x times, use this, 1 over 2 square root of 9 minus x squared times 9 minus x squared prime equals square root of 9 minus x squared plus x over 2 square root of 9 minus x squared times 9 minus x squared prime is minus 2x equals square root of 9 minus x squared minus 2 is cancelled, then x squared over square root of 9 minus x squared, then times square root of 9 minus x squared over square root of 9 minus x squared here, then together 9 minus x squared over square root of 9 minus x squared minus x squared over square root of 9 minus x squared equals 9 minus 2x squared over square root of 9 minus x squared. Then f prime of x equals 0. That means the numerator equals 0. 9 minus 2x squared equals 0. Then minus 2x squared equals minus 9. Then divide by minus 2 on each side. Then x squared equals 9 over 2. That means x equals plus minus the square root of 9 over 2. Then we can rewrite as x equals plus minus 3 over square root of 2. Then f prime of x does not exist. That means the denominator is 0. Then x squared equals 9. Then x is plus minus 3. So critical numbers are x equals plus minus 3 over square root of 2 and plus minus 3. Question 2. In fact, when draw a piecewise function like this, it is much more convenient to simply draw a quadratic function. But we are doing calculus right now, so let's use the derivatives. F prime of x equals, the first one is minus 2x minus 4. If x is between minus 4 and minus 1. The second one is minus 2x plus 2 if x is between minus 1 and 2. The important point here is that both ends of the interval are not differentiable, so there is no equal sign. Case 1. F prime of x equals minus 2x minus 4 if x is between minus 4 and minus 1. Then minus 2x minus 4 equals 0. Minus 2x equals 4. Then x equals minus 2. The number line is here between minus 4 and minus 1. Then f prime of x minus 2. When the testing number is x equals minus 3, use this. F prime of minus 3 equals minus 2 times minus 3 minus 4. Then 6 minus 4 equals 2, which is positive. When the testing number is minus 1.5, f prime of minus 1.5 equals minus 2 times minus 1.5 minus 4. It is 3 minus 4 equals minus 1, which is negative. The curve is like this. Then local maximum at x equals minus 2. Use this. F of minus 4 equals minus 1. To continue using the same equation like this, you can use the store key in your calculator. So minus 4 store x, and then minus x squared minus 4x minus 1, enter. Then you will see minus 1 in your calculator. And then f of minus 2 equals, change the number, minus 2 store x, and then this one, enter again. Then you will see 3. Then f of minus 1 equals 2. Case 2, f prime of x equals minus 2x plus 2. If x is between minus 1 and 2, then minus 2x plus 2 equals 0. Then minus 2x equals minus 2, then x equals 1. There's number line between minus 1 and 2. Then 1 is here. F prime of x, when the testing number is 0, use this. F prime of 0 equals minus 2 times 0 plus 2 equals 2, which is positive. When the testing number is 1.5, f prime of 1.5 equals minus 2 times 1.5 plus 2 equals minus 3 plus 2 minus 1, which is negative. The curve is like this. The local maximum at x equals 1. Then use this and store key. F of minus 1 equals 2. F of 1 equals 6. F of 2 equals 5. First, plot the point we have. This one, minus 4 comma minus 1, minus 2 comma 3, minus 1 comma 2. Make the curve like this. Another one, minus 1 comma 2 is already here, then 1 comma 6 and 2 comma 5. Another curve. Absolute maximum is here. F of 1 equals 6. Absolute minimum. F of minus 4 equals minus 1. Local maximum. This one is also local maximum. Yes, f of minus 2 equals 3. And f of 1 equals 6. The last one, local minimum. F of minus 1 equals 2. Question 3. A local maximum value of 6 at x equals 1. That means f of 1 equals 6 and f prime of 1 equals 0. If f of x graph looks like this, Because leading coefficient 1 is positive, then 1 comma 6 is here. The slope of the tangent line at x equals 1 is 0. That means f prime 1 equals 0. Use this. F of 1 equals 1 cubed plus 3a times 1 squared plus b times 1 plus 2. Then f of 1 equals 6. Then 6 equals 1 plus 3a plus b plus 2. Then 6 equals 3a plus b plus 3. Then 3a plus b equals 3. Then f prime of x equals 3x squared plus 6ax plus b. Then f prime of 1 equals, use this, and 3 times 1 squared plus 6a times 1 plus b. And 0 equals 3 plus 6a plus b. Then 6a plus b equals minus 3. Now we just need to solve the system. So 3a plus b equals 3, and 6a plus b equals minus 3, and minus cancelled, minus 3a equals 6, then divide by minus 3 on each side, a equals minus 2. Then plug in here, 3a plus b equals 3, minus 6 plus b equals 3, that means b equals 9. Therefore, a equals minus 2, b equals 9. Question 4. We need to know where there is a local maximum. When a function has a local maximum at a value, it means that the slope of the tangent line at that value is either 0 or the slope cannot be found. Here, since the function is a polynomial function, the slope of the tangent line can be found anywhere. So we need to find where the slope of the tangent line is 0. F prime of x equals 3x squared minus 6x. We can factor, take out 3x, then x minus 2, then 3x, x minus 2 equals 0, then x equals 0 or 2. So far, we already know that local maximum is at x equals 0 because we can graph polynomial functions. There are two graphs of a cubic function with a local maximum and local minimum, like this or like this. If the leading coefficient, which is the coefficient of the highest degree of the term, this is 1, is positive, the end behavior is down on the left and up on right. So x equals 0 here and x equals 2 here. We already know this, but let's check it out back to the original. The number line is here, 0 and 2, f prime of x. When the testing number is minus 1, use this. F prime of minus 1 equals 3 times minus 1 squared minus 6 times minus 1 is 3 plus 6 is 9, which is positive. When the testing number is 1, f prime of 1 equals 3 times 1 squared minus 6 times 1. 3 minus 6 is minus 3, which is negative. And when the testing number is 3, f prime of 3 equals 3 times 3 squared minus 6 times 3 is 27 minus 18 equals 9, which is positive. The curve is like this. That means local maximum at x equals 0. That means f prime of 0 equals 0. The local maximum value is 5. Then f of 0 equals 5. Then f of 0 equals, use this, 0 cubed minus 3 times 0 squared plus c. And f of 0 equals 5. Then 5 equals 0 minus 0 plus c. That means c equals 5. Now f of x equals x cubed minus 3x squared plus 5 because of this one. And then local minimum is here. Then f of 2 equals 2 cubed minus 3 times 2 squared plus 5 is 8 minus 3 times 4, which is 12 plus 5 equals 1. Then f of 2 equals 1. This is local minimum. This is the last one. F prime of x equals 3ax squared plus 2bx plus c is a quadratic, so it can have 0, 1, or 2 real roots. That means f of x has either 0, 1, or 2 critical numbers. The quadratic equation ax squared plus bx plus c equals 0. The discriminant is b squared minus 4ac. And now discriminant is 2b squared minus 4, 3a times c, which is 4b squared minus 12ac. Case 1, the discriminant is less than 0. There is no critical number. If f of x equals x cubed plus 2x, then f prime of x equals 3x squared plus 2. Then this one is always positive. That means the discriminant is 0 minus 4 times 3 times 2, which is always negative. The graph is like this. If f of x equals ax cubed plus cx, then a and c is always positive. That means f prime of x equals 3ax squared plus c, which is positive. Then discriminant is 0 minus 4 times 3a times c, which is always negative. So no critical number. Case 2, the discriminant is 0. That means there is one critical number. If f of x equals x cubed minus 3, then f prime of x equals 3x squared. Then 3x squared equals 0 when x equals 0. The graph is like this. In here, f prime of 0 equals 0. So if f of x equals ax cubed plus d, then d is any real number. Of course, a is not 0. Then f prime of x equals 3ax squared. And 3ax squared equals 0 when x equals 0. And the critical number is 0 minus 4 times 3a times 0 is always 0. Case 3, the discriminant is greater than 0. There are two critical numbers. If f of x equals x cubed minus 3x squared, then f prime of x equals 3x squared minus 6x. We can factor 3x times x minus 2 equals 0. Then x equals 0 and 2. The discriminant is minus 6 squared minus 4 times 3 times 0 is 36, which is always positive. The graph is like this. Then f of x equals ax cubed plus bx squared plus cx plus d. F prime of x equals 3ax squared plus 2bx plus c. The discriminant is 2b squared minus 4 times 3a times c, which is 4b squared minus 12ac. If any combinations then makes discriminant is always greater than 0, that means there is two critical numbers. I hope this video has been helpful. The previous lesson is linked in the description bar below. If you have any questions, leave them in a comment. Thank you for watching. Please like and subscribe for more.